12 identical wires of resistance are each are joined to form a cube. Calculate the equivalent resistance of the cube between A and B as shown in figure 1. So we have to find the equivalent resistance between A and B, between A and B, between A and B. Let us find the equivalent resistance between A and B.
Of this cube, each side is of resistance R. Let us find the effective resistance between A and B. This is A point, this is B point. Let us find the effective resistance between A and B. So if a battery is connected between A and B, then the potentials of this point and this point are same. Similarly, the potentials of this point and this point are same. So let us call these 2 points as C1, C2. Let us call these 2 points as D1, D2. We can join C1, C2 and D1, D2 without affecting the current distribution. So we can join C1, C2. We can join D1, D2. Now, so the given arrangement is equivalent to this. This is A point, this is B point, this is C, this is D. So now these two parallel resistance R by 2, these two 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 resistance R by 2, this is single resistance R, this is single resistance R. We can find the effective resistance between A and B. These three are in series, then this is in parallel with this, then again this will be in series, that will be parallel with this.
If a battery is connected between A and B, C1, C2, same potential, D1, D2, same potential. We can join C1, C2 to form C, D1, D2 join to form D, A to C, R by 2, because A to C1, A to C2, this is R, this is R, these two are parallel, so A to C is R by 2. Similarly, we can find the other resistances. These three are in series. This is 2R. These two are in parallel with R by 2. The effective resistance of these two resistors are R into R by 2 by 2R plus R by 2. So this is R square by 5R by 2. So this is 2R by 5. This is 2R by 5. 2R by 5 in series with R by 2. R by 2. It is 7R by 5. 7R by 5 in parallel with R. It is 7R by 12. 12 identical wires of resistance are connected in this way. We have to find the equivalent resistance between A and B.
Of the cube, each side is of resistance R. Let us find effective resistance between A and B. This is A point, this is B point. We need the effective resistance between A and B. If a battery is connected between A and B, then the potential of this point and this point are same. Let us call the points to be C1, C2. Similarly, the potentials of this point and this point are same. Let us call the points to be D1 and D2. We can join the same potential points without affecting the current distribution. So I can join the C's this way and I can join also the D's this way. So the arrangement is now this. This is the arrangement. This is A point, this is B point. We need the effective resistance between A and B. So let me rotate this. This is A point, this is B point. We need the effective resistance. This is R by 2, 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 this is R, this is R. Then the potential of this point and this point same. So this R by 2 can be removed without affecting current distribution. This is similar to balanced Wheatstone bridge. Then we can find the effective resistance between A and B. This is R, this will be R by 2, R by 2 in series. This is R, this is R. This is already we have removed this one. This is similarly R by 2, R by 2 series.
Let us find effective resistance between A and B. If a battery connected between A and B, C1, C2 same potential, D1, D2 same potential, we can join C1, C2 to form C. We can join D1, D2 to form D. In this way there will be no change in the current distribution. So this is A, this is A, these two combination is C. So A to C, the resistance this and this parallel making R by 2. Similarly, F to D is R by 2, D to G is R by 2, C to B is R by 2, then C to D is R by 2. So these R by 2, these are series. This is 3R by 2. This is also 3R by 2. This 3R by 2 divided by R by 2 is equal to 3R by 2 divided by R by 2. So this is the balanced Wheatstone bridge. So this resistance can be removed. Hence the arrangement is equivalent to this. Here no R by 2. Then these two in series. This is 3R. These two in series. This is R. These two are in parallel. So this is 0.75 R. Then we need the effective resistance between A and B.
This cube, each side has resistance R. Let us find the effective resistance between A and B. So this point is A, this point is B. If a battery is connected between A and B, then the potential of this point and this point are same. Let us call the points to be C1, C2, C3. Similarly, the potential of this point this point same. Let us call the points to be D1, D2, D3. D1, D2, D3 have the same potential. Similarly, C1, C2, C3 have the same potential. We can join C1, C2, C3 and we can join D1, D2, D3 without affecting the current distribution. So the given arrangement is then same as this arrangement. So this is the equivalent arrangement. This is A point, this is A point, this is C1, C2, C3 combination, this is D, D1, D2, D3 combination, this is B point. So this is A, this is C, this is D, this is B. This resistance is R by 3, this resistance is R by 6, this resistance is R by 3, because 3 are in parallel, 6 are in parallel, 3 are in parallel, this R by 3, R by 6, R by 3 in series. We can find the effective resistance between A and B.
If a battery connected between A and B, the points C1, C2, C3 are of same potential. We can join them to form C. The points D1, D2, D3 are of same potential. We can join them to form D. A to C, the total resistance is R by 3 since these are parallel. Between B and D, the total resistance is R by 3 since these are parallel. Between C and D, the total resistance is R by 6 since these two and these two are in parallel. This R by 3, R by 6, R by 3 are in series. So the effective resistance is 5 R by 6. 12 identical wires of resistance are 1 ohm, each joined to form a cube. A battery of 7 volt is connected between A and B. Calculate the current along each edge of the cube. Battery connected between A and B, C1, C2, same potential, D1, D2, same potential. Already I have discussed this earlier. So the effective resistance is 7R by 12. Since R is 1 ohm, it is 7 by 12 ohm. Let I current flows. This I current will flow this way. Then this will be divided. Let I1 flows this way. I2 flows this way. I1 plus I2 must be equal to I. This 7R by 5, that is the combination of these three resistors. So this way I1 flowing, this way I2 flowing. This 2R by 5, this is the combination of these two. Hence I1, I2, then I2 divided, I3, I4. This 2R is R, R by 2, R by 2. So from C to F, there are two resistors parallel. Current is I4. Hence through each resistance, current is I4 by 2. C to F, I4. So C to F, C to F, I4 by 2, I4 by 2. G to D, I4. So G to D, I4 by 2, G to D, I4 by 2. Similarly, we can find current in other edges. I is 7 volt by 7 by 12 ohm. I1 is 7 volt by R. I2 is 7 volt by 7R by 5. These two are parallel. So I3 into R by 2 is I4 into 2R. I4 is I2 minus I3. Then from this we get I3 equal to 4 ampere. Since I3 4 ampere, I4 has to be 1 ampere. And this is I2 by 2, we can find accordingly. This is I4 by 2, we can also find this current. Similarly, all the currents we can find. Each resistor is 1 ohm. A battery of 9 volt is connected between A and B. We need the current along each edge of the cube. C1, C2 same potential. We can join to form C. D1, D2 same potential. We can join to form D. D, C are of same potential. So this R by 2 can be removed. Hence, the effective resistance is 0.75 R. Let current I flows. I divided I1, I2, same I1, I2 flowing, I1 flowing, I2 flowing, no current flows along DC path. 3R by 2, this is the series combination of R and R by 2. So I1 flowing, I2 flowing from A to F, I2 flowing from F to D, I2 flowing. There are two resistors parallel, so through each resistor current will be I2 by 2. F to D, F to D, it is I2 by 2, it is I2 by 2. I is 9 volt by 0.75 R. I1 is 9 volt by R. I2 is 9 volt by 3R. Then finding these, we can solve all these currents. We need the current along each edge of the cube. Battery of 20 volt EMF is connected between A and B. The points C1, C2, C3 are of same potential. We can join to form C. The points D1, D2, D3 are of same potential. We can join to form D. These three resistors are in series, so the total resistance is 5R by 6. Let current I flows. This I flows in this path. Since this is 3 resistors parallel, through each resistor current is I by 3. Since 6 resistors parallel, through each resistor current is I by 6. Since current I flowing C2A, so C2A I by 3, C2A I by 3, C2A I by 3. Since current I flowing D2C, so D2C I by 6, 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 D2C I by 6. Current flowing B to D I, So B2D I by 3, B2D I by 3, B2D I by 3. I is 20 volt by 5 R by 6, since R is 1 ohm. So it is 20 volt by 5 by 6 ohm, it is 24 ampere. Knowing I, we can find current in each edge of the cube.